Let's do this problem. The problem essentially says there is a block on the top of ice and it slips on ice. At what point the velocity is high enough that it loses its contact with ice? To do this, we need to find velocity of the block when it has fallen a height. We use conservation of energy equation, which is potential energy plus kinetic energy must be the same at all times. We get this equation. We don't want to solve now. Here, if you noticed, we consider the potential energy at the ground as 0. Let us now look at the circular motion and look at forces acting on the block. There are two forces. Normal force, which is always perpendicular to surface and is radially outward, and gravity, always downwards. The forces provided are in general imbalanced and provide the circular motion of the block moving through ice. The force along the radius is equal to centripetal force, which is mv squared by r. The gravitation along radius is minus mg cos theta. Normal is radially outward. We have taken radially outward as positive. When the block just loosed the contact, the n is 0, and we get this equation. Now, we solve these two equations. We go to another slide which shows the same equations to solve. We reduce it. We now have to calculate height, which is r, cos theta, when it loses contact with ice, so that we have to eliminate velocity from these equations. We do this by substituting v squared from lower into the top equation to get this. And then we get r cos theta. R cos theta is height, and that is the answer. This ends the video.